Thank you, sir. Good morning, everyone. Respected session chair, respected faculties, guests, fellow presenters, and all the participants. My name is Ronen Acharya, and I'm delighted to present in front of you here to present about our project RF-based home electrical control system. So this was basically our second year project, second year academic project. The team member includes myself, Ronen Acharya, Sandeep Banjara, Mr. Consimaria, Mr. Sanjay Prajali, and our respected supervisor, Mr. Ronen Acharya, sir. This will be the outline of my presentation, and I will go through the different tests and results that we have occurred during the course of our project. Well, in today's age of advancement, the technical advancement especially is done to ease the regular human activities, regular human tasks. As we talk about Industry 4.0, Industry 5.0, which significantly includes the concept of automation and human-machine interfaces, designing such system to automate regular household activities to take control over household appliances could be a better technical project. Well, there are several wireless technologies such as IR, infrared, Wi-Fi, RF itself, for making a wireless control over the household appliances. Our project basically aims to develop a 433 MHz RF-based system for wirelessly controlling the household electrical appliances, reducing the need of direct physical contact with the switchboards. Talking about the problem definition, as of now, the control over the household appliances is typically based on the wall-mounted switches. And most of the people are quite adapted the thing, controlling the appliances with the wall-mounted switches. But for the people like mobility challenges, old age peoples, and general people like us having a busy day at the work, controlling the household appliances wirelessly and making some sorts of automation could be a way to ease the daily household activities. Manual system may also pose to high safety risks, particularly for the young children. So it's a big threat for us if we have a kid of about, let's say, 5 years old. They may poke the metal object like spoons or forks and knives into the socket board. So this is a very risky thing to use electrical socket and plugs in such scenarios. And existing technologies like IR itself to control over the household activities is based on the line of sight requirement. So controlling the television, normal television with the IR remote is quite possible, but if we are talking about to control the household appliances, it limits the IR technology limits due to its line of sight requirement, as there may be the walls, obstacles, furniture in the household setting. The objective of our research is to design and construct the RF-based system for wirelessly controlling household appliances using a compact handheld remote, and to ensure the safety and convenience by reducing the need of direct physical interaction with the switchboard. So we are not just making a convenient system, but we are making a safer approach to control over the household appliances. These are some of the literature reviews of some related projects we have done that implies several technologies such as IR itself and GSM techniques. Now, talking about the methodology, the approach we followed to complete the project, the methodology could be better explained by dividing the entire working in the three sections: transmitter section, receiver section, and the power management section. So I'd like to go through the individual sections. Transmitter section, it basically is a user interface. So it's a handheld remote that primarily consists of push on-off switch. So it is controlled by the user, and the push on and off states are considered as a parallel data, which is sent to the encoder IC. So here, as we are using ST12E, encoder IC. It is a 12-bit encoder. So 4 data are to be given by the user, and rest of 8 parallel data are of the address bits. The encoder converts parallel data into the serial data, which is then transmitted to the ear by the transmitter module. Upon transmitting the serial data into the ear using RF module, the receiver antenna receives the signals. It then sends the received serial data into the decoder IC. Here, decoder IC, it converts the serial data into the 12-bit parallel data. First, it verifies the address bits, and address bit, if it matches with the transmitter section and receiver section, then only it proceeds to the relay control that controls over the different household appliances. Power management section is a central power management unit for the receiver section. So as receiver section, it includes the different control circuitry and high voltage electrical appliances control. So the receiver section itself consists of a centralized power management section that consists of a 12-012 transformer coupled with the rectifier circuit. 7805 voltage regulator is used to provide 5-volt supply to the circuitry, and 220-volt AC supply will be triggered using the relay module itself. This is the conceptual flowchart of working of the project. So, as said initially, upon starting of the, upon powering the remote or the transmitter module, the condition of the switch, either it is on or off, is fed into the encoder IC that converts the parallel data to the serial, and later the RF transmitter module, it sends the encoded signal wirelessly. Talking about the receiver section, which also includes of the power management system. First, if the power management system is working, the RF captures the transmitter signal. It first decodes and verifies the address with the transmitter module and the receiver module. So then it moves toward the second stage of decision making. If the received address is valid, that is the address of both transmitter and receiver end are validated, then it proceeds toward the relay control circuit. Otherwise, it loops back to capture the transmitted data. This particular decision module represents the logic for operating the relay. These are the major components used in the project. The transmitter section primarily includes push on-off switch that acts as a user interface, ST2 value encoder IC, and RF transmitter module that works on 433 MHz frequency. RF receiver module on the receiver end, ST2 value decoder IC for decoding process, and the relay control for controlling the home appliances. Now I'd like to go through the result and discussion part. So to ensure the reliability and functionality and efficiency of the project, so a series of tests were performed, and as this was our second year project, we were quite fascinated about the wireless communication thing. So we had verified and studied about the different features that modules and circuitry we have used. First, we have tested the encoder-decoder address pin user study. Here we can see the A0 to A7 are the address pins, that is 8-bit, and AG11 is the point where our switch is placed, having the corresponding output on the G11. So here the transmission is validated using the VG LED. If all the address are matched, then only the transmission is validated and the output is done. So this particular concept is used to make the pairing, and but having a predictable and unchanged address pins have a threat to hacking through the signal spoofing. ASK verification was done in the oscilloscope. So 2 test cases was made when no buttons are pressed and when all the buttons were pressed. So here we see the significant change in the amplitude, frequency, and the phase shift. So here we verify the modulation technique of the modules. This was the circuit simulation done in the ProTips design suite. a test was done for the antenna length study. So being a second year student, we were quite fascinated about how antenna things work. And we came to know through our study that the standard size for antennas was were a quarter or half the wavelength of the antenna. So we have taken three test cases without antenna, quarter wavelength antenna, and half wavelength antenna. We took the actual measuring scale and verified the range. This was the test results. Upon using the half the wavelength antenna size, we get up to the 100 meters of range. All different test was done for combination logic type control system. So as we are controlling four outputs, using the concepts of digital logic, we took two inputs and made the circuitry. However, this two switches to control four outputs appear to be correct theoretically, but is less practical in the real world. This was the PCB designing process, and this was the final PCB of the project. The AC load was tested using the PCB's inbuilt relay. A reliability test was done using the different power sources. This was the final prototype demonstration. So to conclude my presentation, the study successfully demonstrated the feasibility of using RF communication to use the home appliances control. The design system, thus no use of microcontroller, provided cost-efficient and user-friendly and scalable alternative. This will be the future work of the project in expansion. These are the references, the final PCB description, demonstration setup, and these are the project members. Thank you.
Thank you for your wonderful presentation. So yeah, any questions from the floor? No questions. Okay, then I have questions. So very first question. I mean, normally we start with RF in home appliances. Okay, this is used for long distance communication, but you try to use that. That's pretty amazing. So my first concern is like when you use this frequency 433 megahertz, have you checked whether that frequency is comes under the armature band?
Sorry, sir?
Have you checked this frequency comes under the armature band or not?
Actually, we had used this particular frequency for RF because the module we are using that offers that particular frequency, 433 megahertz.
I understand, but okay. But normally when you use the frequency, you have to check because this armature band is not allowed to use with unless you have the license of the armature band.
Yes, sir. The frequency we are using comes under the non-licensable.
Okay, if you have checked that, because when I see the range, it's quite near to the armature band. And normally to use the armature band, you have to take a license. Normally we use this kind of frequency in the satellite, basically in the low Earth orbit. So that was my first concern when you say the frequency so high. I was thinking that it won't be that high. Okay, anyway, that was my first question. And the second thing, my concern is like when you say the power management system, right? I didn't see the battery backup. Like you have just the AC power, right? And suppose in the practical scenario, if you are using the system in any home and if the electricity is gone, then the home automation is gone, right? I didn't see that. That is something in the battery management system you have to incorporate. Otherwise, it will not be the practical solution. Okay. So one more question, like you say that you have the 4-bit for the user, right? So that means 2 to the power 4 is 16. That 16 is the maximum number of the devices that you can control. Okay, so when you give that number of bits, right, it goes in a different ASK modulation, all right? So do you think the ASK modulation can penetrate the wall?
Yes, sir. Our verification by controlling the loads on the next room from the next room was done in between the wall.
Okay. If you have done that, then I believe on you. But normally, it's not that easy to get it through. Okay. Thank you. Thank you for.